In this video, we're going to go over how to solve absolute value inequalities involving less than signs. Let's check it out from a conceptual perspective. We're not going to memorize stuff. Let's dive in. So it says solve and graph each. In letter A, we've got a basic example. It says the absolute value of x is less than or equal to 6. Now let me heavily suggest, if you haven't already done so, learn how to solve absolute value equations first in the previous videos before moving into this. So this means that the distance that x is from 0 is less than or equal to 6. I suggest graphing out first to see what's going on here. So if the distance that x is from 0 is less than or equal to 6, that means that it's either at 6 or less or greater than negative 6. So it's somewhere in here. And think about it. If the distance that x is from 0 is less than or equal to 6, within 6 away from 0 is another way of saying that. So that would be all the numbers between negative 6 and 6 with the or equal to including it. So how do we solve it? We translate out of the absolute value into the inequality that this graph represents. So that would be from negative 6 is less than or equal to x, which is less than or equal to 6. So the secret is understanding it as the distance from 0 is less than or equal to 6, and that would be 6 to the left or 6 to the right, and everything within those boundaries. And then using your skills in compound inequalities to go from the graph to that. And if you're having trouble on compound inequalities, check out some videos on that first, bone up on it, and then you'll be in good shape. All right, let's step it up a notch. In B, we've got the absolute value of x minus 17 is less than 14. So the way that I think of this is, as I've done in previous videos with absolute value, I think of all of that as stuff. X minus 17 is all in the absolute value. Its distance from 0 is less than 14. What does that look like? Well, the distance that x minus 17, or stuff, is from 0 is within 14. So that means that it's all the way out to 14, but not including 14, and then also to the left 14. Because if the distance is within or less than 14, you're either 14 to the left or 14 to the right, and everything within. So we're going to shade everything in between them. There we go. Now translate what you see here into a compound inequality, and we will have dealt with the absolute value sign. So stuff, or x minus 17, is between 14 and negative 14. So it's greater than negative 14, but less than 14. Not including the 14s because there's nowhere equal to. The good news is all we now have to do is solve this inequality. So all I have to do is add 17 to both sides, and the inequality will be solved. That's sweet. You know I think so. So 17 and negative 14 is 3. The x minus the 17 canceled, so we just have x, which is less than 14 and 17 is 31. So what that means is all numbers between 3 and 31, not including 3 and 31, when plugged into this, will have an absolute value that's less than 14. Pick a number and test it. Let's pick 30. That's to the left of 31. 30 minus 17 is 13. The absolute value of 13 is 13, which is less than 14. Nice. I'll pick a number like 5. That's greater than 3. 5 minus 17 is negative 12. The absolute value of negative 12 is 12, which is less than 14. It works. Awesome stuff. All right, one last problem here. We'll challenge you. We want to isolate the absolute value first. Just like in solving any inequality, you want to undo the order of operations like you're solving an equation. And the order of operations would be plug in a number for m, take the absolute value, multiply by 5, then add 14. So we want to undo addition by 14 first. So I subtract 14 from both sides, and that's going to leave me with 5 times the absolute value of m, which is less than or equal to, the 14's cancel, 29 minus 14 is 15. We isolate the absolute value of m by dividing both sides by 5. Sweet. The 5's divide out, and that leaves us with the absolute value of m. Now, that's not our final answer. We still need to undo the absolute value. Some students will fall into the pit of just saying, oh, I'm done. Not quite. This says the distance that m is from 0 is less than or equal to 3, or within 3 of 0. So again, I like to at least visualize the graph, so I'm going to show you what's going on in my mind. So if we're a distance of 3 away, that's in either direction, and that's including 3. And it's all the numbers between, because it's either to the left 3 or to the right 3 and everything within it, less than or equal to 3. So now from here, all I've got to do is do what this inequality graph tells me to do. So that's going to be -3 is less than or equal to m, which is less than or equal to 3. The name of the game, y'all, absolute value means that number's distance from 0. Graph it out and take that graph and use it as a compound inequality. Some teachers teach this as less than, so it's like an and inequality, and there's no math in that whatsoever. So if you're going to memorize it that way, at least please understand the concept so that you can rock and roll in later math studies of inequalities. In a later video, we'll go over the, well, greater than type of inequalities with absolute values. Can't wait to see you there.